Hello everyone, in this video we are going to learn about solving for absolute value equations. Before we begin, let's talk about what is an absolute value. Well, an absolute value is a number's distance from zero, which is why it is always going to be positive. For example, the absolute value of 5 is always going to be 5. And the absolute value of -5 is also going to equal to 5. If that's a little bit confusing, let's take a look at this graph here on the right. As we can see, an absolute value equation on a graph looks like a V, and that V basically tells us that there's always two solutions. For example, here, looking at this point, from the middle, from 0, it is 1, 2, 3 points away. And if we go to the left, it is also 1, 2, 3 points away. So that is why we always get two solutions. So let's take a look at these two problems. And we need to think which one is valid. So let's see. Remember that x just represents a potential number. So we need to think what is a potential number that the absolute value would give us 7. Well, we know that the absolute value of 7 is equal to 7. And we also know that the absolute value of -7 is also equal to 7. Therefore, when it comes to solving absolute value equations, the first step that we're always going to do is that we're going to separate and make two equations. One where x must equal a positive number, and one where x must equal a negative number. And those are our answers. X could either be 7 or -7. Here on the right, we see that the absolute value of x is equal to -5. But now, is there ever an absolute value that will give us a negative number? Well, let's see. Let's use our solution. X has to equal 5, and x has to equal -5. Now let's plug it back in. Will the absolute value of 5 equal to -5? Definitely not, because the absolute value of 5 is 5. Therefore, there is no possible number that when it is asked for the absolute value that will give us -5. So this will be no solution. So just to clarify what we've talked about so far, in order to solve an absolute value equation, we always have to account for two possible answers, one that's positive and one that's negative. So we always make what is inside the absolute value equal to a positive answer, like we did here, and equal to a negative answer, like we did here. Now, if already from the beginning the absolute value is equal to a negative number, that is no solution. That is going to be invalid. Now let's take a look at these problems, where now we have an actual equation inside of the absolute value. But we're going to follow the same steps that we did in the first problem. So we're going to create our two separate possibilities, where x minus 4 could equal to positive 3, and x minus 4 could equal to -3. Now we're going to solve this using our inverse operations. Here, this is -4, so we are going to add 4 on both sides, and we get x is equal to 7. And here, I'm going to add 4 as well on both sides, and I get that x is equal to 1. You should always do the same steps twice, but get different answers. Now you're probably wondering, shouldn't one be negative and one be positive? The thing is that keep in mind that we have an equation inside the absolute value, not a singular number. So here, if I were to plug 7 back into x and 1 back into x, so now the idea is that x would now be 7 minus 4 and is equal to 3. And now the absolute value of 7 minus 4 will give us the absolute value of 3, and the absolute value of 3 is in fact equal to 3. But now what if I were to plug in this x equals 1? Well, I would get 1 minus 4. 1 minus 4 would give us the absolute value of negative 3. And the absolute value of 3 is in fact 3. So that's how we know that we could get our solutions right. But now let's take a look at this problem on the right. As we spoke about earlier, there are no possible numbers that when inside an absolute value could give us a negative number. Therefore, that already looking at this problem right here, we know that is no solution. So now take a moment to try these problems out. And when you're ready, unpause the video and let's work on it together. Looking at this first one, I already see that it is equal to negative 2, which is impossible. So I already know that this first one is no solution. Now for the second one, we're going to follow the same steps that we did earlier, where we created two possibilities of what x could be. We have x minus 3 is equal to 2, and x minus 3 is equal to negative 2. Here, I'm going to simply add 3 on both sides, and I get x is equal to 5. And here I'm also going to add 3 on both sides, and I get x is equal to 1. Now let's test them out. I'm going to do that over here. The absolute value of 5 minus 3 is equal to 2. 5 minus 3 is 2. Now the absolute value of 2 is in fact 2. So that's right. Now let's try 1 out. The absolute value of 1 minus 3. 1 minus 3 is equal to negative 2. And the absolute value of negative 2 is in fact 2. So therefore, both of these are my solutions. So x could be 5 and 1. Now take a moment to try this problem out. And when you're ready, unpause the video and let's work on it together. Now the only difference in steps about this one is that there's just one more additional step when it comes to solving the equation. But we're still going to make our two separate equations, where we do 2x plus 1 is equal to 9, and 2x plus 1 is equal to negative 9. And now we just still solve like normal, using our SAD map. 2x plus 1 equal to 9. We're first going to subtract 1 on both sides, and I get 2x is equal to 8. Lastly, I'm going to divide by 2 on both sides, and I get x is equal to 4. Here I'm going to do the same thing. I'm going to subtract 1 on both sides, and I get 2x is equal to negative 10. I'm still going to divide by 2 on both sides, and I get x is equal to negative 5. Therefore, my two solutions would be x is equal to 4 and negative 5. And let's test it out. The absolute value of 2 times 4 plus 1. 2 times 4 is 8 plus 1. 8 plus 1 is 9. And the absolute value of 9 is in fact 9. Now what about negative 5? Let's test it out. 2 times negative 5 plus 1. 2 times negative 5 is negative 10. Negative 10 plus 1 is negative 9. And the absolute value of 9 is in fact 9. Now looking at this equation, we have a little problem, which is that our absolute value has some friends outside, this plus 3. Now this absolute value has to be completely alone before we apply our steps. So before solving for that absolute value, we have to get rid of that 3, which means that we're going to use our same inverse operations. This plus 3, we could move it to the other side by subtracting it on both sides. And we are left with the absolute value of 2x minus 5 is equal to 8. Now we could actually make our two equations, where I make 2x minus 5 equal to positive 8 and 2x minus 5 equal to negative 8. And now let's solve like normal. I'm going to add 5 on both sides, and I get 2x is equal to 13. And if I divide by 2 on both sides, I get x is equal to 13 over 2. And I'll write that over here just so it looks a little bit more clear. Here I'm going to add 5 as well, and I get 2x is equal to negative 3. I'm going to divide it by 2, and I get x is equal to negative 3 over 2. Well, let's check. Let's plug it into our original equation. I get 2 times 13 over 2 minus 5 plus 3 is equal to 11. 2 times 13 is 26. 26 divided by 2 gives us 13 as well. Minus 5 plus 3 is equal to 11. 13 minus 5 is 8. Plus 3 equals 11. The absolute value of 8 is just 8 plus 3. And 8 plus 3 is in fact 11. But now let's check negative 3 over 2. The absolute value of 2 times negative 3 over 2 minus 5 plus 3 equals 11. 2 times negative 3 is negative 6. Divided by 2 is just negative 3 again. So you get left with the absolute value of negative 3 minus 5 plus 3. Negative 3 minus 5 is just negative 8. So I have the absolute value of negative 8 plus 3 equals 11. The absolute value of negative 8 is in fact 8 plus 3, and 8 plus 3 is equal to 11. So now take a moment to try this last problem. I know it looks intimidating, but just try it out, using the same inverse operations that we've been practicing before. And remember, you want to isolate that absolute value before moving on. So when you're ready, unpause the video and let's work on it together. Well, the first thing I want to do is I want to isolate this absolute value. So first of all, I want to get rid of this 2. So let's get rid of that. We always want to get rid of whatever is farthest from it to whatever is closest. So since 2 is what's farthest from it, that's what we're going to get rid of first. And I get left with 4x minus 6 over 3 is equal to 7. Now here I'm dividing by 3, so in order to get rid of it, I'm going to multiply both sides by 3, and I get left with the absolute value of 4x minus 6 is equal to 21. Now I'm going to work on it over here so that I have more space. Now I'm going to make my same two equations. 4x minus 6 is equal to positive 21, and 4x minus 6 is equal to negative 21. Now let's solve. I'm going to add 6 on both sides, and I get 4x is equal to 27. I'm going to divide both sides by 4, and I get x is equal to 27 over 4. Here I'm going to add 6 on both sides. I get 4x is equal to negative 15. I'm going to divide by 4 on both sides, and I get x is equal to negative 15 over 4.